Hi everyone, welcome to my channel. So today I'm going to show you the how to solve the simplex algorithm method. So we have our problems here. So I can see it's a max problem. We have to maximize the profit, and the profit equation we have, and we have some subjective functions. So subjective function does, which is a constraint, 3 constraint we have. So what we have to do is just primarily we have to form our initial table. So let's start with it. The first we have to do is form the initial table. This is our step 1. Let's consider it as step 1. So in step 1 we have to form the initial table, initial simplex table. So write it. Initial simplex table. So this is the first step we have to form. So the first thing before doing it in initial table step 1, first we have to do is convert these inequalities into equations. How are we going to do this? We already said that we have to add slide variables. So let's do it. Convert those equations, inequalities to equations. Converting inequalities to equations. So the first one, following this, watch the screen. I'm showing you x2 as this is the first one. So we have to we say it in our 12th video number 12, that what we're going to add in this case. Obviously we are using slide variables as there's a less or equal, so we have to plus add s1 is equal to 36. Same for the second one, 5x2 plus s2 equal to 40, 2x1 plus 4x2 s3 is equal to 28, and this is our converting equation. Second, what we have to do is we have to constraint equation into matrix form. I mean, we have to convert these equations into matrix forms. So what it looks like. So in matrix form, so first take this coefficient of these equations first, 6, 2, 1. Okay, as you are seeing there is no s2 and s3, so add 0 and 0 here. So first, second one, 5 and no s1, so it's 0, s2 1, no s3, so 0. In case of third one is 2 for x1, 4 for x2, and no s1, so 0, no s2 also, so it's 0, and s3 is like this, so s1. And the variables are x1, x2, s1, s2 and s3 equal to this constant 36, 40, 28. So this is our matrix form. In matrix forms, this equations are in matrix forms. It looks like this. This is our first step, but second case. So we're going for the third case. So from that we have to we have that we have our matrix formation. So what we have to do is just form the initial table right now. So let's consider it as portion 3. In portion 3 we have to build up the simplex table, initial simplex table. So first consider it as x1. This is the initial table we're developing for our mathematics. X2. First write all variables we have in our math. These are basic variables and these are our slack variables, and add it and constant. Okay, from that matrix table, from that matrix we have the coefficient right in here, just as like the matrix. 2 1 0 0 5 5 0 1 0 2 4 0 0 1, and in here all constant we have 40 28. Okay, and how we going to add this line? So in previous, as we seen that we have a Maximus problem, which was pi equal to 5x1 plus 3x2. So in this case, you have already seen that there is only x1 and x2. There is no s1, no s2, no s3. So that is the thing we have to add in here. That is the we have to just take the coefficient of that formation. So as there is no s1, no s2, and no s3, so this will be 0. The first we have to take the negative coefficient of that equation. So let's take it as -5, as there is +5, so we have to take the negative one as -5, then -3, that was +3. So, and there is, as there is no value of no coefficient for s1, s2, and s3, so all will be 0. And in case we are also seeing that there is no constant at the end. Let me clear it, that just watch here. What we have is pi equal to 5x1 plus 3x2, and this is what we had. This is what we had. So what we did is just take this portion in the left side. So so what's this? That pi minus 5x1 3x2 and equal to 0. So this is the basic thing what we had done in here. So in this here you're saying there is minus 5x1 minus 3x1 and no s1, s2, and s3, so all will be 0, and for constant it's 0 also, so add 0. So this is our initial basic table. This is our initial table. Okay, for step 1 is fourth portion. In portion 4 we are going to read this table, like from this initial in the screen you are seeing what I'm going to write, what we have to write in this portion. I'm not writing in here because it is wasting my time. So you are seeing in the screen, I'm just reading. Okay, so in fourth step we have to just read this table. So by reading this table, what we are finding that the first basic feasible solution can be read from this initial simplex table is the value of x1 is 0. How it is 0, I have told you. I'm suggesting you to follow the video 14. Then you will realize how we have found the value of x1, because there is no 0 and 1 in x1 column, so the value of x1 is 0. Same for x2, the value of x2 is also 0, because there is no 1 and 0 in x2 column. And the value of s1 is, the 1 is here and rest of the 0, so it's 36. and S2 is 1 is the second row and is 40 and rest of the 0, so S2 is equal to 40. In case of S3 is 28. So this we can from the initial table we can see the basic things. The variables, value of the variables are looks like this, and at the first basic feasible solution the objective function has a value of 0, so the objective function value is 0. Objective function value is 0. So from this table, objective function value is 0. Here is it is 0. So this is what we are going to do in the fourth portion of step 1. Okay, so here we are in step 2. In step 2 we have to do two things. The two things is, in step 2 we are going to find the pivot element. We are going to describe the pivot element and the change of basis. Okay, pivot element. Okay, and change of basis. Change of basis. This is our step 2, that finding the pivot element and changing the basis. So first, in step 2, number 1, we are going to find the pivot element. So how are we going to find the pivot element? The negative indicator with largest absolute value determines that the variable to enter the basis. Since -5 in this table has negative indicator with the largest value, will be considered as the pivot column, and yeah. So first thing we have to do is find the pivot column. For step 2, I'm suggesting you to follow the video 14. That will help you to find realize how we are going to determine the pivot column and pivot row. So this is step 2. In first case, you have to describe what I'm seeing, so it's showing in my screen. So that is how we are going to find the pivot columns. That looks like the last line, the last row. From this row, you have to find the largest absolute value that is holding with a negative indicator. Largest absolute value with negative indicators will be considered as pivot column. Like if you see in here is 5 comparing with other elements, like it's 0, 0, 0 and it's 3 and it's 5, and 5 has a negative indicator, so it's going to consider as our pivot column. So this is our pivot column. Okay, this is our pivot column. Okay, then this was the first one, how we're going to find the pivot column. And in case of step 2, second element, second step 2, second issue. So in here we are going to find out the pivot row. Then we have to find the pivot column. Okay, finding the pivot column. Pivot row. Okay, finding the pivot row. So in case of finding the pivot row, what we have to do is, I have already shown you in my 14th video that we have to find the displacement ratio. So we right now we have the pivot column, and 6, 5 and 3 are our pivot columns element. So finding the displacement ratio, we already know how we're going to find the displacement ratio. So it's very simple. that you have to divide the constant with same same rows pivot element. Like this is our pivot columns element. So if in case of 36, you have to divide 36 with 6. If our pivot column could be this second one, so what you have to do is 36 divided by 2. So as our first column is our pivot column, so finding the displacement ratio, what you have to do is just 36 will be divided by 6. Okay, so let's check. 36 divided by 6 equal to 6. Okay, in case of the second one, it will be 40 as our constant. It will be divided by 5. So here 40 divided by 5 is 8. Okay, and the third one, it will be divided by 28 divided by 2. So do it. 28 divided by 2 is 14. So this is our displacement ratio. So finding the pivot row, what we have to do is just find the smallest one. So among these three, 6 is the smallest one. So that's mean if we divide 36 divide 36 by 6, so its displacement ratio will be lowest comparing with rest 2. So the first row is our pivot row, as it is holding the lowest displacement ratio compared with rest 2. So this is our pivot row, and the intersection of pivot row and pivot column will be considered as pivot element. So 6 is our pivot element. So right here, pivot element is equal to 6. So our pivot element is equal to 6. So I'm suggesting you to find out how we have found the pivot row and pivot column. I'm suggesting you to watch video 14 if you didn't understand this. That will help you to understand how we are going to find out the pivot row and pivot column very well, because video 13 and 14 are the basic of simplex algorithm in my channel. So we have completed step 2, so we are heading for the step 3. Step 3.